Normal ice. This is the solid form of water most people see every day, formed when liquid water freezes at 0 degrees Celsius. It is found in freezers, lakes, and cold environments around the world. What makes it different is its simple crystal structure and clarity. Ice crystals actually form in a hexagonal pattern, which is why no two snowflakes are exactly the same. It matters because it is the most common and useful form of ice in daily life, used for preserving food, cooling drinks, and even supporting ecosystems under frozen lakes where fish survive beneath it. Without it, many cold region environments would completely change. Black ice. This is a thin, nearly invisible layer of ice that forms on roads when moisture freezes. It commonly appears in cold regions during early mornings or nights when temperatures suddenly drop. What makes it unique is how it blends perfectly with the road surface, making drivers think it's just wet asphalt. Even experienced drivers can lose control instantly without warning. It matters because it is responsible for some of the most sudden road accidents in winter, and it forms so quickly that even salt treatments sometimes fail to prevent it. Dry ice. This is frozen carbon dioxide, not water, and forms at extremely low temperatures of about -78 degrees Celsius. It is produced for industrial use, medical transport, and special effects. What makes it different is that it doesn't melt into a liquid. Instead, it sublimates directly into gas. That gas creates a thick fog-like smoke, which is why it's often used in concerts, horror effects, and movie scenes. It matters because it allows items like vaccines and biological samples to be transported safely without electricity for cooling. Blue ice. This is dense glacier ice that appears blue due to the way it absorbs and scatters light. It forms over hundreds to thousands of years under extreme pressure inside glaciers. The deeper the ice gets, the more air bubbles are squeezed out, making it clearer and denser. What makes it special is that it can look almost glowing blue when light passes through it. It matters because it reveals how ancient ice layers transform over time and helps scientists understand glacier movement and climate history. Glacier ice. This forms from layers of snow compressed over thousands of years in very cold regions. It is found in massive glaciers and ice sheets in places like Antarctica and Greenland. What makes it different is that it is one of the oldest natural materials on Earth, sometimes containing air trapped from tens of thousands of years ago. Scientists can extract ice cores from glaciers to study ancient atmospheres. It matters because it acts like a frozen archive of Earth's climate history, helping us understand how the planet has changed over time. Sea ice. This is frozen ocean water that forms in polar regions. Unlike normal ice, it contains salt and forms in shifting seasonal cycles, growing in winter and shrinking in summer. What makes it unique is that it constantly changes size, affecting global weather patterns. It also reflects sunlight back into space, helping cool the planet. It matters because even small changes in sea ice levels can impact sea levels, wildlife like polar bears, and global climate systems. Fragile ice. This consists of tiny loose ice crystals that form in supercooled, fast-moving water. It is often seen in rivers, waterfalls, and turbulent ocean areas at the start of freezing conditions. What makes it different is that it doesn't form a solid sheet immediately. Instead, it looks like floating icy slush moving with the current. It matters because it is the very first stage of ice formation and can later freeze into larger blocks that affect river flow and even hydroelectric dams. Anchor ice. This forms underwater when ice attaches to rocks, plants, or riverbeds in extremely cold flowing water. Instead of forming on the surface, it grows upward from the bottom. What makes it unusual is that it can lift objects or trap fish by freezing directly onto underwater surfaces. It matters because it can disrupt ecosystems, change river behavior, and even damage underwater infrastructure like pipes or turbines. It's kind of wild when you think about it. Something as simple as frozen water can exist in so many forms across the planet. And that's where I'll leave it.